So Leetcode practice. In this video, there are two goals. The first goal is to see how to solve this problem, and then we are going to do some coding work. And the second goal is to see how it should behave in a real interview. So let's get started. So in the real interview, the first goal is always try to first understand the problem. If there is anything unclear, please bring up the question. And also at the same time, think about some edge cases that you need to treat especially in the next step. So let's see. Range sum query 2D, immutable. So given a 2D matrix, find the sum of the elements inside the rectangle defined by its upper left corner and the lower right corner. So the above rectangle is defined by row 1, row 2 with 2, 1, and row 1, col 1 as 2, 1, row 2, col 2 as 4, 3, which contains sum as 8. Alright, so I think it's pretty clear about the question. Let's think about if there's any edge cases. So let's see the notes. You may assume that the matrix doesn't change, and there are many calls to the sum region function, and you may assume that row 1 is smaller or equal to row 2 and col 1 is smaller or equal to col 1. So we don't need to worry about the illegal row 1, row 2 stuff, but there's still some question I think that's unclear. So for example, is the matrix going to be empty? Like the number of rows is equal to 0, or the number of columns is equal to 0. And also if row 1 and row 2 and column 1 and column 2 are within the number of the rows and the corresponding number of the columns within the matrix. So if the row 1, row 2, column 1, column 2 could be out of range. So those are the questions in my mind, but let's assume that we have a matrix which is not going to be empty, and also let's assume that the row and columns, the upper left corner and the bottom right corner are within the range of the matrix. So let's start with that so that we don't need to worry about those special edge cases. So the next step is about finding a solution. So how to solve this problem? So the solution wise, what I can think, maybe we could use some dynamic programming to record some status. So let's see how to do it. So the first thing that comes in my mind is we could so for each row we could calculate the prefix sum, and then when we are trying to call the sum region, then we just need to, because we have the prefix sum of each row, then we just need to for each of the row within the sum region, then it is going to be O1 regarding the calculation. So for example, for this specific matrix, we have the sum row prefix sum for the row 2, 3, and 4. So for calculate this region, we just need to use prefix sum for this cell minus the prefix sum for this cell, and then we are going to get the sum region within all of n. And is the number of the columns within the subregion. But let's see if we could do it any better than this. So let's see. Let's see if so this is defined by 2, 1, 2, and 1. Okay. So let's see if so I think we can have a better way to do it. So what if we start, so first of all we define this as the arrangement. So what if we compute so for a certain point, what if we compute the sum of we compute the sum of the sum region from the origin point to the current point. So for example, we compute all the numbers within this rectangle, and we put the number to be here. And by the way, we need to define a DP array, a DP matrix for this. So the number put in the DP matrix for this index would be the sum of this part. And similarly, we are going to compute all the elements within the DP matrix we define. To compute the sum region of this, we just need to get the corresponding number from the DP matrix of this index, and this index, and also this index. So it would be like DP here minus DP here minus DP here plus DP here. So then it would be, we will be able to calculate the sum region of the corresponding of the defined sum region. So for this one, to calculate the constructor, would be O M N. So M is number of the rows and N is the number of the columns. And for sum region call, it will be all of 1 regarding the runtime. So let's do some coding work on this approach. I think currently this is the best approach we could think of. So the next part is about coding. So how to code. So in the coding part, you need to care about the speed. Don't be too slow, and also the correctness of the code and the readability of the code. So let's see num matrix. First of all, we need to define a private number. Let's say we define call it sum from origin, and then in the constructor we have rows as equal to matrix dot length. Remember, we have the assumption that the matrix is not going to be empty. So this is matrix 0 dot length. So we are having sub from origin as equal to new int row and columns. So we are going to have int i's starting from 0, I smaller than so how? So if we so I think first of all we could do is we could assign the value for the first row and the first column. Then it will be easier for our computation, but let's see if it's then I think it will be easier for our other computation. Let's say I is equal to 0, I smaller than the row, and plus I. So you're going to have matrix I0 as equal to this is sum from origin as matrix I0. Similarly for the first row, j is equal to 0, j is smaller than column, plus j, and 0 j is equal to matrix 0 2j. Okay, so this I will be starting from 1 to row, and j would be starting from 1 to the column. So to compute, so the sub from origin ij, it will be equal to sub from origin. First of all, it is I So it is I minus 1. So this is the last row stuff plus the sum from origin I j minus 1 stuff, I j minus 1, which is the next column. Yeah, so what I was trying to do is to compute this cell. So for example, to compute this, let's say to compute this cell, we need to, so we could get the sum from origin of this and sum of origin of this, get them together, plus it, minus sum of origin this plus the matrix value of this. So minus the sub from origin I minus 1 j minus 1 plus the matrix ij. Yep, that's the sum sub from origin computation of that. And then to compute the corresponding region, we just need to return. So let's assume that row 1, column 1, row 2, column 2, it's within the range of the matrix. So this will be just the return sum from origin row 2, col 2, so minus sub from origin, this is row 2, column 2. So this one we should have the, so we should, if this is if row 1, column 1, so this is a row 1, column 1, this is row 2, column 2. So what we need to do is we need to subtract this part. So let's see. Int sum as equal to this. This is for sure to be good. I would say if row 1 is larger than 0, then we need to subtract minus equal to sub from origin okay, so this is sub from origin row 1, column 2, and similarly, if column 1 is larger than 0, which means if the column 1 is larger than 0, but like here, if the column 1 is smaller than 0, then we actually have nothing to minus. The sum minus equal to sub from origin this is row 2, column 1. Okay, so this is, let's take a look at this example. This one would be, okay, so this is actually minus 1, and this is also a minus 1. So if it is this the row and column, we are going to subtract this part. This part is row 1 minus 1, column 2, and this part is row 2. This is row 2, column 1 minus 1. Okay, and also we need to take a look if row 1 is larger than 0 and column 1 is larger than 0, then we need to have sum plus equal to sub from origin. This is row 1 minus 1, and then this is column 1 minus 1, and then finally we return sum. Because we have subtract this area twice, so we need to add it back. So I think that's pretty much it about the code. Remember, after we are done with coding, it's time for us to do some testing. For testing, so the one way is to just go through a simple test case, and at the same time do some sanity check and explain how this piece of code is gonna work. So let's see if the matrix is something like this. Let's compute so the first row subfrom origin is going to be exactly everything from the first row, and first column is going to be everything from the first column. So to compute, let's say to compute this one, what we are going to do is we have subfrom origin I-1j, which is this. So and then from origin ij-1, which is this here. So minus the sub from origin I-1 j-1, which is this, and plus the corresponding thing I here. So plus minus this, so this one will be 3, sorry, it is 5 plus 0 minus 3 and plus 6. Yeah, so I think this is the logic for to compute the sub from origin. And let's see if we are going to calculate something. We are going to call some origin API. So let's say this is a row. This is a row 2 column 2. This is row 1 column 1. So we are going to have row 2 column 2, which is the sum of this region, and because the row 1 is larger than 0, we are going to subtract the row 1 minus 1 column 2. So row 1 minus 1, which is this row, column 2 is this column, so we are going to subtract this region from it, and we are going to minus row 2 column 1 minus 2. So this is row 2 and the column 1 is this, so column 1 minus 1 is this, so we are going to subtract this region. And also because row 1 is larger than 0, column 1 is larger than 0, we are going to add back this area, because we essentially subtract this area twice. So let's see, I think it works, it looks good. Let's fix some typo here. So line 11 here. Alright, so it seems like it's accepted. Let's give it a submission. It's runtime error, array index auto. Okay, so it seems like our previous assumption that the matrix is not empty it doesn't apply in this system. So we definitely need to deal with that kind of case especially. So if I would say if row is equal to 0, then we just return, and if column is equal to 0, then we simply return. They should handle the empty matrix stuff, but I'm not sure if there is any like out of the box. So okay, so output is none, minus 5, minus 5, minus 4, minus 5, minus 1. So let's see why. We have the matrix as minus 4, minus 5, and when we call the 0101, we are so when we call this 01, we are actually returning a minus 5 from our output. But okay, so actually when we try to get the sum from a region, we are actually wrong. It should be instead, it should be if so okay, so this one should be starting from 1, say sub from origin. So this definitely the bug. So 0 0 as matrix 0 0, because we are defining sum from origin as the sum, so we cannot simply set it as the original number from the matrix. Instead, we should be is equal to sub from origin. This is I minus 1 0, something like this. And similarly, we are going to have this as j minus 1. So I think this is going to cover so this is going to cover the bug. Yeah, so that's it for this coding question. If you have any question about the solution or about the code, please leave some comments below. If you like this video, please give me a thumb up and help us subscribe to this channel. I'll see you next time. Thanks for watching.